Okay, I'm going back to this worksheet that was some practice problems dealing with cross-sectional areas that are perpendicular to a surface. And so I already did number one, A and B, but I'm going to do it again. Okay, so here I go. I'm going to start over here, and I remember what this was. It was okay. We can use a calculator, whatnot. And now, since I'm not on Zoom, when I use a calculator, you're not going to see me keying anything in. If I use a calculator, I may not even finish the whole problem. I may set it up and then make you finish it on your own calculator. Okay. One. Find the volume of this solid whose base is bounded by the graph of y equals x plus 1 and y equals x squared minus 1. And the indicated cross sections with perpendicular, taken perpendicular to the x-axis. We're going to start with the square. Okay, so we're going to start with squares. And so my equations, basically, I have my x plus 1, which is that function. That's x plus 1, that function. Then I have x squared minus 1. That is g of x equals x squared minus 1. And the bounded region will look something like this shape here. And you need to picture that being laying on the floor. We're looking straight down. If you're looking straight down and out comes squares, if you're looking straight down, all the squares are going to look like this. I'm trying to make them perpendicular to the x-axis. Let me go this way. That's a square coming out. 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 You're just looking straight down. And all I see is all these squares that are beautifully coming out. And if I could turn this around and look at it from the side, I would have this region here on the floor. I don't even know how I'm going to pretend to draw it, but and then what's going to happen is if I look at one of those squares coming out, it's going to look like that. And this side here is the same as this side here. If I do another square closer to this tip looking from a side version here, that's going to be a smaller square. Then if I look at one that's going to be a bigger square than this one, but it's still a square. So imagine a whole bunch of these coming straight up, looking at it that angle here, straight up. And so looking straight down, I just see the tops of those squares. So what I need to realize is that the cross section are squares. All the cross sections are squares. And so, yes, the area of that square is side by side. But how do I create the side? I create the side by finding this distance right here. And it's the same formula even if I'm down here. The only thing that changes is the x value changes. That's a different x there than the x here. Those are different x's. So in terms of x, that distance is the top function minus the bottom function. So when I label it, my top function was x plus 1, and my bottom function was x squared minus 1. So that side in disguise is really x plus 1 minus x squared plus 1, or negative x squared plus x plus 2. Both of those sides are that. So the area of that square would have been s squared. In other words, this times itself. And so that's my area. But in reality, though, the square also had depth. It had a thickness. And the goal is to get as thin as I possibly can. So for practical purposes, we say that the width of every square, look at it right here. The width of this square, the thickness, I better not use that color, is a dx. It's a small portion of x values. It's a change of x's from the left side of the square to the right side of the square. Delta x is what you called it before, but because it's so small and we're talking about infinitesimally small, we refer to it as dx. So the volume of that figure, once I have all those squares all in there, packed in there nicely, will be volume will equal to my limits. And we did this problem. You could go to your calculator and find where these two intersect because one x starts here and the last x is up here. So I think we did it. You should all remember it. I think it was -1 to 2. Now I have to take that side, which is related to x. When x changes, the side changes. It was -x squared plus x plus 2 squared dx. And yes, we could FOIL that out. When I say FOIL it, I would have to really waste a whole lot of time and multiply it out because the way it's written right now, you can't integrate this with any substitution. Trust me, I tried. Nothing works. The only way to do this particular problem is to multiply it out by distributing it and creating 3 times 3, 9 different terms. Then you'd have to simplify it, and it's just a lot of work. So I will let the calculator do the walking, and I will just go to my calculator and I'll type that in. I'm not going to type it in again because we did this already in class. I'm going to go look at my answer to see if I remember what it was. I think it was 8.1. Let me go back and look here. Yes, it was 8.1. So, and it was exactly 8.1. So I don't have to say approximately with 3 decimals because it was exactly 8.1. All right, so that was with the squares. Now B says rectangles of all height 1. So the only thing that changes is the picture is going to stay the same. I'm going to have this y equals x plus 1 as my f, and then the parabola was g. So those functions are the same, and the shaded region is the same, but out comes out almost like the squares. It looks the same from the top. If I draw them, it looks the same from the top, just a whole bunch of rectangles. But what's different is the height of every one is the same. So if I pull one of those out, let me take it at a slanted angle. It's going to have a height of 1, sticking straight up. That distance, and let me do it better than that. The square's going perpendicular to the axis, so there it is. And the one that's up here too looks the same. I mean, it's going to be smaller this way, but the height's the same. For both of those, the height was 1. The height is 1. But this time, the difference between F and G is the length of that rectangle. So every rectangle has f of x minus g of x as that length, but the height standing straight up will be a 1. So this time, my volume, the limits upper and lower are the same, -1 to 2 of my, how did I simplify that over there? I think it was a -x squared plus x plus 2. This time it's not squared because it's this times 1, which is this, dx. This one actually you could do by hand because I'm not squaring it. I did it with a calculator. I'll come back and see what the answer was. Hold on. You should do it too. I'm back. It was 4.5. Let's see if we can do it by hand, make it work. When I integrated that, that would become a negative x cubed over 3 plus an x squared over 2 plus a 2x. All of this from a negative 1 to a 2. The odds of getting it right is pretty slim because there's a lot of places to make a dumb mistake. If I plug in a 2, 2 cubed is 8, so that's a negative 8 cubed. Plug in a 2, that's a 4. 4 over 2 is a 2. Plug in a 2, it's 2 times 2 is a 2. No, it's 4. All of that, subtract, plugging in the negative 1. A negative 1 cubed is still a negative 1 times this negative makes it a positive 1. That makes it a 1/3. Negative 1 squared is still a 1. 1 over 2 is going to be plus a half. And a 2 times a negative 1 is a negative 2. So that gives me a negative 8/3 plus 2 plus 4 minus a third minus a half minus a 2. I'll be really impressed if I get it right. So should you be. The plus 2, wait, that should be a minus 2, shouldn't it? That'd be a plus 2. So the negative 8/3 minus a third would be a negative 9/3. So I got those done. A 2 plus a 2 is a 4. And a 4 minus a half, a 4 minus a half would be 3.5. So let me just go 3.5. And then a negative 9 divided by 3 is a negative 3 plus 4 plus 3.5. A negative 3 plus 4 is a 1. 1 plus 3.5. Hey, let me go buy a lottery ticket. I got the answer that the calculator gave. I did it by hand. Yay. I can see some of you just amazed at my skills. Okay. And I don't know why I'm working on the front page because I have this same page. But that's okay. I'll finish up. You know what I'm going to do? I'm going to go to the next page to do the equilateral because this is the hard part. This is where I don't think I got through this in any class here where all three problems could. I need a whole lesson on equilateral triangles because let me set it up for you. I have the same region. No surprise. You're not impressed at all. It's the same region. And you got the same parabola. And you're going to have the same flooring, okay? The same floor. But this time, out pops out. Well, it's kind of interesting. If you look at it from the surface, it all may look about the same. You won't even see triangles coming out. But in reality, if I draw one of them very clear, you can see it. It is really an equilateral triangle. Whatever side this is, that side's the same. Even here on the small one, it's still going to be equilateral triangles. So I basically need the area of that cross section. I need the area of that cross section. I'm still going from negative 1 to 2, so that's no secret. So I'm integrating, my volume will be integrating negative 1 to 2 of what area, and that this has a thickness, which is a measurable dx, a dx thickness. So whatever area I get, dx. So let me go over here and try to give you a little lesson on equilateral triangles. And we just don't use equilateral triangles very often, so it's not your fault. Forgive them. They don't know what they do. So if I want to do an area of a triangle, and this is equilateral, so I'm going to call, I better not use the S. I better not use the X. I better use S's, okay? That's a side. That's the same side. That's the same side. And the area of a triangle is always 1/2 base times height. Well, here's the problem. And my battery may not make it, but hopefully it will. Here's my base. It's the bottom. It's called S. And then here's this height. Well, how am I going to find the height of this triangle? What I want you to do is picture only half that triangle. That means this is S, this is half of S, and this is my height. So I'm going to relate my height to the S's. I'm going to use Pythagorean Theorem. H squared plus S over 2 squared has to be S squared. H squared has to be S squared minus S squared over 4. Keep going. H squared equals 2. I'm going to put a magic 1 underneath that and do my magic fractions. How do I subtract that? 4 times S squared is 4S squared minus 1 times S squared is S squared, all over the 1 times 4, which is 4. Take this, well, let me finish simplifying. 4S squared minus S squared is 3S squared over 4. Take the square root, both sides. H will be, I only need the positive, the square root of 3 over the square root of 4 times the square root of S squared. Turns into square root of 3S over 2. So there's the height. Square root of 3 over 2 S times S, right? Yes. So the area of this triangle right here will be, let's do the area of this triangle. That area will be 1/2 times the base, which is labeled 1/2 of S, 1/2 of S, times the height. So there's my base. No, there's my base. There's my 1/2. 1/2 times the base. The height we said is square root of 3 over 2S. Square root of 3 over 2 times S. There's my height. Put that all together. I have 1/2 times S over 2. And there's another 2 here, so there's an 8 here. 1 times S times S makes it S squared, and there's a square root of 3. Square root of 3 S squared. But that was only for this triangle. The whole triangle is 2 of those. So the whole triangle, the whole equilateral triangle, and you should memorize this formula because it comes up all the time. Area equals 2 times square root of 3 over 8 times S squared, which really is, the 2 cancels out from down here, square root of 3 over 4 times S squared. All right, memorize that. Now, go back up to my notes over here, square root of 3 over 4 times S squared. Here I go. Change color. Square root of 3 over 4 times S squared. But I don't use S now because, well, okay, let's pretend I use S. What really is S? Remember what S is really? It's F minus G. S is really the F minus G. Let me do it better than this. Volume is from -1 to 2, because this really isn't correct. Square root of 3 over 4 times, we've done it so many times, it was a negative x squared plus x plus 2 dx. Oh, I have to square it. And so this is a job for my calculator. Volume equals to, I can pull out the square root of 3 over 4. It's just a constant. Now I'm integrating from -1 to 2 of negative x squared plus x plus 2 dx. But you know what? We've done this integral before. It was 8.1. So I'm just going to say square root of 3 over 4 times the 8.1, if you recall. And that's my story, and I'm sticking to it. What did I need you to get out of this? What's the area formula for an equilateral triangle? You know what I could have done? I could have Googled it. Oh my goodness, what a waste of time that I just did. All right, move on. Look, what was it? Oh, it was The whole one was right here. Square root of 3 over 4 times s squared. Try to memorize it. Square root of 3 over 4. Example 2. This time, find the volume of the solid whose base is bounded by this circle, and each cross section that's perpendicular to x. The first one are squares. Okay. So what does this equation look like? That's a circle. So it starts here, goes around, and the radius is 2 squared. The radius is 2. This number is always r squared. So I know this goes to 2. I know this goes up to 2. I know this goes to negative 2. And this is also a negative 2. He wants me to use this region. Let me shade it in. This region is the floor. And I want squares that are coming out. So from the top, here's what they look like. All I see is this. Now, I'm going to make this problem a little easier. I'm only going to look at the top part of the circle. You could use this whole square. You really could. You could just take the whole square and realize that the side of this square has to be the same as the distance between the top and the bottom. So it isn't going to be a surprise to you to realize that that square is going to be smaller, but it's still the distance between the top and the bottom. But it kind of gets complicated when you say the top function f is, let's see, if I take this function and solve it for y will be 4 minus x squared square root. I take 4 minus x squared, take the square root. Positive. What the heck? I'll just leave it like that. That's f, okay? F is the positive square root of 4 minus x squared. That means the bottom piece down here, called g, will be the negative of the square root of 4 minus x squared. I mean, that's how you graph one of the circles with your calculator. You do the top, you do the bottom, okay? So that distance here, the side of the square, will always be f minus g. In this case, it's going to look really weird. F is the square root of 4 minus x squared. Then I'm going to minus negative of the square root of 4 minus x squared. That becomes a plus. That turns into 2 times the square root of 4 minus x squared is that side of the square. So here I go. Here's that square. This is 2 times the square root of 4 minus x squared. This side is 2 times the square root of 4 minus x squared. And the area of this squared will be side times side. So area is 2 times the square root of 4 minus x squared, all of it squared, is 4 times the insides. 4 minus x squared. Because when you make a square root times a square root, cancels out the radical. All right, there's the area of that square. But remember, this square has thickness. It's really not a square. It's a prism with a very thin height, if you were to lay it down. If I lay it down, you wouldn't hardly see it. You know, it's very thin. Matter of fact, how thin is it? dx. Why is it dx? Go back to my picture here. It's dx because if you were to make it thicker, just so you can see it, a little thicker square here of the base, this distance here is a difference called delta x. Even though it's small, it's still a delta x. So we call it dx. All right? Let's do the calculus. So far, I haven't done any calculus. Here goes. volume will be from some number to some number, and that's what I need to ask you, times the area, which was 4 times 4 minus x squared dx. Okay? Now, how do I get the numbers? Let's see. What x does the squares begin? The farthest x is right here, -2. And it continues to make squares until I get to the 2. Well, that was kind of easy. -2 to 2. Here's one I could probably do also without a calculator. Matter of fact, on your mark, get set, go. You key in a calculator and see if you beat me. Here goes. That's 4 times -2 to 2 of 4 times 4 minus x squared dx. Oh, wait, no. I meant to pull the 4 out. Then it's symmetrical. I can take 2 of only from 0 to 2. 2 of those times 4, it makes it 8 times 4 minus x squared dx. That turns into 8 times 4x minus x cubed over 3. From 0 to 2, I plug in my 2. I may have lost you on that. Why had that turned to an 8? Because I'm not going from -2 to 2. I'm just going from 0 to 2 to make it easy. Did you beat me yet? You may have, because I keep talking. That's 8 times 4 times 2 is 8, minus 2 cubed is 8, 8 over 3. So that's minus 8 over 3. All of that minus the 0. 8 times 0 minus 0. Okay. So the answer is going to be, oh, I don't know how it went over. How did it go over there? I don't know. I know you're probably now bored because you're already done. Show off. 64 minus 64 thirds. I don't know what the calculator says, but I'll just finish it up. Put a 1 under here. 3 times 64 is 180 plus 192 minus 64 over 3. 192 minus 64 is, I don't know, 36 plus 92. I mean, I don't know how to do that in my head. 36 plus 92. 6, 7, 8, 9, 10, 11, 12, 128. 128 over 3 will be my volume. And that's the answer I'm sticking with. Unless, I hope I'm not totally wrong. I would say thumbs up if I'm right, but we're not on Zoom. Okay. Oh, wait, I'm not done. That was just the first one. Now I have to do the same circle with equilateral triangles, and I'm going to do B. Here it goes. Same circle. Would help to draw the circle. Same circle from -2 to 2. This time, out pops out equilateral triangles. Notice this one's bigger than that one. And this one right here is super tiny. It's a baby coming out. Okay? If I only knew the formula for the area of an equilateral triangle. What was that formula? If you forgot, go back times S squared. So area was square root of 3 over 4 times the side squared. And where does the side come from? I'm glad you asked. It came from the top function minus the bottom function. And I wonder what that is. My side was, let me go back and look over here. What was my side? It was 2 times the square root of 4 minus x squared. Why should I do all that work again? 2 times the square root of 4 minus x squared. That's the side in terms of x's. Here goes. Let's get the work done. Volume will be, my inner limits will still be -2 to 2. No, it won't. I'm going to go 2 times the integral from 0 to 2 times my side. Squared times square root of 3 over 4. So here it goes. Square root of 3 over 4 times my side squared, which would be 2 times square root of 4 minus x squared, all squared dx. That can simplify a lot, okay? Because the square root of 3 over 4 can come out, so that gives me 2 times square root of 3 over 4 gives me square root of 3 over 2, 0 to 2. 2 squared is a 4. When you square the square root, out pops out 4 minus x squared dx. Look, I'm still simplifying. Pull out the 4. 4 over 2 is 2. 2 square roots of 3 from 0 to 2 of 4 minus x squared dx. This integrates simply, or please use your calculator, but let's see. I was on a roll. That's 2 square roots of 3 times 4x minus x cubed over 3 from 0 to 2. And when I plug in the 0, this goes to, will this go to 0? No, it doesn't go. Oh, yeah, that was a 4x. It does go to 0. Shoo, I got scared. So 2 square roots of 3 times, plug in the 2, 4 times 2 is 8, minus 8 thirds. You see a pattern? It's almost always the same. 8 thirds. All of that minus, plug in the 0, 0. Okay, so here's my answer. I'm going to distribute the 2 square roots of 3 twice. Here goes. Or if you wanted to, you could just add those fractions together and leave 2 square roots of 3 and just say, well, what is 8 minus 8 thirds? That would be, put a 1 there. That's 24 minus the 8 all over the 3. Yeah, I kind of like that. That turns into 2 square roots of 3 times 16 thirds. 16 times 2 is 32 square roots of 3 over 3. By the way, all of these should be some unit cubed, whatever the units were, but I don't think they've given me any units. Unless I made a major mistake, and I could have, because look at all that work, okay? I'm sticking to that answer. I'll let you use your calculator and double check it. Please let me know if I'm wrong. Okay, where am I at now? That was B. C is semicircles. Okay, those getting easier. The hardest ones, guys, are those equilateral triangles. Semicircles. So here's the same graph. Here's the same circle. Everything's the same, but out pops out. Let me just draw one of them. Out pops out. I don't want to do a shading gray. I want to do this. Out pops out a semicircle. That semicircle is smaller than this semicircle, which is bigger than this semicircle. All I need to know is what's the area of that cross section. Interesting. The bottom of each of these semicircles, I'll call it the bottom, which is the same formula as my side was on the other problem. The side was, and I don't have it memorized, was, where was it at? 2 times the square root of 4 minus x squared. So that's 2 times the square root of 4 minus x squared. And then that's this distance here. Do I need that distance? Maybe I don't even need technically this answer, because how do I find the area of a semicircle? It's half. Area is 1/2 of the radius squared. This side is actually 2 of the radii. So the whole side is 2 of the radii. I want half of that. So radius will be half of that side. Half of 2 times square root of 4 minus x squared. That cancels out, so my radius is simply the square root of 4 minus x squared. So my area now is equal to 1/2, because I'm not doing the full circle, 1/2 pi times the square root of 4 minus x squared all squared. That turns into pi over 2 times 4 minus x squared. Because when you square the square root, it goes away. So there's my area formula. Let's do calculus. I want every circle from the very end, where it's just a dot, to the next semicircle, on every semicircle from -2 to 2. So my volume is from -2 to 2, not volume's going to be 2 times 0 to 2 of pi over 2 times 4 minus x squared dx. Pull out the pi over 2. That means it cancels with this 2. Volume's going to be a pi times 0 to 2 of 4 minus x squared dx. Could you just use the calculator from -2 to 2? You certainly could have. But so far I'm on a roll, I think. That gives me pi times, the integral will be 4x minus x cubed over 3. All of that from 0 to 2. And what happens when I plug in 0 again? You're right, goes to 0. So all I really care about is pi times an 8 minus 8/3. Why, I've seen that before. That's the same as pi times 24 minus 8 over 3. That's the same as 16 pi over 3 units cubed. Okay, what a beautiful job. And I might be talking fast because I'm not entertaining you in front of Zoom right now. I'm just going through them. You can stop it. You can slow down. You can actually message me if I'm wrong. Okay? So stare at that for a minute. What did I say my answer was? 16 pi square roots of 3. That was C. What is D? D is, okay, isosceles triangles with the hypotenuse as the base of the solid. So what's an isosceles triangle? An isosceles triangle means two sides are the same. And then this is my base of that triangle. Oh, he said the hypotenuse. It must be, it's not just isosceles. It has to be an isosceles right triangle. So that must mean that's a right angle here. I could be wrong. That would be a right angle, and that would be the hypotenuse. Okay, that's the hypotenuse. So let's see, how would I do the area of this triangle? I'm going to draw it differently. I'm going to draw it like this, side times side, and I'm going to draw this as my hypotenuse, okay? I'm winging this. I've never done this problem before. And I should draw the picture. What's the picture going to look like? Let's see. Circle. -2 to 2 again. But out comes out these. Here's the hypotenuse on the base. And this side is equal to this side. I'm really concerned because those sides, how are they related to this base? I know what this base is. It's f minus g again, this whole thing. But how is s, the side, related to it? That's going to be tricky. So let me go back up to here and say, if I draw it this way, let's see, hypotenuse. This, I'm going to know what it is. It's always going to be, what was the side again? The distance between the one semicircle to the other semicircle. I wish I had it memorized, but I'm not going to lie to you. I don't. I wrote it down several times. Let's see. What was the side? 2 times the square root of 4 minus x squared. So every single time this hypotenuse is 2 times the square root of 4 minus x squared. Every single time. But what is these sides going to be? I'm thinking. I've got something for you. It's a 45, 45, 90-degree triangle. And you're asking me, how did I know that? Well, I had to keep thinking. So whatever this side is, this side's the same, and the hypotenuse will always be the square root of 2 times this side. So if I go backwards to get these two the same, let's see, how do I go backwards? If all I know is that this number is a 5, then I think I have to divide by square root of 2, I think. I don't know if it's going to work. Let's see. Yeah, because square root of 2 divided by square root of 2 is a 1. So if I divide this by this 5 by the square root of 2, that's what gives me 5 over the square root of 2, 5 over the square root of 2, and that's a 5. Let's see if it works. I'm going to use Pythagorean Theorem to check it because I don't even know if it's going to be working. 5 over the square root of 2 squared plus 5 over the square root of 2 squared is supposed to be equal to 5 squared. When I square 5, that's a 25. When I square square root of 2, that's a 2. When I square the 5 squared, that's a 25. When I square the square root of 2, I get a 2. Is this equal to 5? I'm just checking it because I don't really know. 25 halves plus 25 halves. Oh, it's supposed to be squared. Oh, yeah. Half of 25 plus half of 25 is 25. 12.5 plus 12.5 times 2 is 25. It works. Okay, I figured it out. So now, if I take this hypotenuse and I divide it by the square root of 2, that's what each of these sides will be. Oh, I feel so happy. I don't even know if I needed all that. Anyway, I'm going to write it out. This side is 2 square roots of 4 minus x squared divided by the square root of 2. This side is also the same thing. 2 square roots of 4 minus x squared divided by the square root of 2. I don't even know if I need all that. Did I need all that? Oh, I don't think I needed all that because what did I need? I needed the area of this triangle. Oh, but I did need it in terms of x's. So I got x's on every single side. All right. We're still working hard. Area of this isosceles right triangle will be 1/2 times this times this. Base times height. Well, check it out. It's the same thing being squared. So it's going to be 2 square roots of 4 minus x squared over the square root of 2. So I did need that number. Squared. That's base times height. There's times a half. Boy, this is ugly. 1/2 times, if I square the 2, that turns into a 4. If I square the square root, that turns into 4 minus x squared. If I square the square root of 2, that gives me a 2. Equals to? 2 times 2 is 4. With a 4, cancels out. What am I left with? 4 minus x squared. What? Can it be that simple? That the area of an isosceles triangle that I just did now is 4 minus x squared? I I don't really know. That's kind of weird. I'm going to keep working and see how the calculus works. Okay, here goes. Here's the calculus. Volume starts with negative 2 to 2, just like always. But I'm going to go 2 times 0 to 2. And I just got done doing the whole area formula. I hope it's correct. If it's wrong, I'm not doing it again. 4 minus x squared dx, because it has a thickness. This is too simple. I can't believe this is going to work. This is 2 times 4x minus x cubed over 3 from 0 to 2. And when I plug in the 0, it goes away. So hopefully it is the 2 times 4 times 2 is 8 minus 8/3, which turns into 2 times 24 minus 8 was 16/3, which turns into 32/3 cubic units. Units cubed. I can't believe that's right. I mean, it's just, it looks too simple. Okay? Please double check my math. See if it seems kosher to you. Okay, I just peeked at all the answers. Every one of them was correct. I can't believe it. I'm like, wow. All right. There's one more problem. I don't know if I want to do anymore. I think the point is made. The hardest part was, what's the area of a semicircle? And that was, that area, well, square was s squared. And then the semicircle was 1/2 of a circle, pi r squared. And the equilateral triangle was, wasn't it square root of 3 over 4 s squared? Square root of 3 over 4 s squared? I don't really remember. So you might want to go back and look at the other page. So let's do A here. First of all, let's see what the region is. The base of the solid is formed by a cubic. Okay, well that's easy. A positive cubic starts down here, comes up nice and pretty, goes up and keeps on going. Okay. And y equals to 0. Well, that's easy. Y equals to 0 is this line here. And x equals to 1. Is that what it says? 1. So here's the region. It's this pretty, let me do shading. It's this pretty region here. Okay. And the first one, you know what I'm going to do? I'm going to copy this picture. I'm going to show off my skills. I'm going to, whoop, battery's getting lower. Whoop, I don't want to do that one. Don't know what I'm copying here. Copy. I don't even know if I copied it or not. I didn't paste anything. Oh yeah, I just pasted the whole thing. I don't want to paste the whole thing, but I think I just did. So I have different copies. Oh, okay, that's cool. I have different copies. I can share this. Look at that. I have 3 of them here. So let me move this one way up here. Move this one way out here. Okay. So here's my first one here. A square. So I'm going to zoom in on here and say, as I look at this, here I see a bunch of squares. Squares coming down from that curvy thing. And each square is dependent on how long f minus g is. In this problem, this is my f and this is my g. F is x cubed. G is 0. These distances here for the square, let me do the square here. That's a square, and it's going to be side times side. And the side's going to be f minus g. It's going to be nothing more than x cubed. And another x cubed, because x cubed minus 0 is still x cubed. That's easy. The area of this square will be x cubed squared, which is x to the 6. And because every x gives me a different square. Limits. This is just too easy. We know that it crosses the origin. That's 0. We know this is a vertical line 1. So that's going to be a 1. So volume will be from 0 to 1 of the area of those squares, which is x to the 6 dx. This is just too simple. Is x to the 7 over 7 from 0 to 1. The answer to this problem is 1 to the 7th power over 7. 1/7 units cubed. Boy, that was almost too simple. Hope it's correct. Okay. The answer is correct, but I didn't read the problem correctly. Find the volume of the solid. I should have finished. If each of the following cross sections are perpendicular to the y-axis. Oh my gosh. How could I be so... This is like a 7th grader. I didn't read it. I did perpendicular to the x-axis. I like it. Axis, x-axis. I got to do this again because I didn't follow the directions. So what I'm going to do is I'm going to find this. Here it is. Here's the second one. I have time to reprieve myself. Here goes. I'm sorry. I was on a roll. I did all those other problems perfectly. They're going this way. Perpendicular this way. Perpendicular to this axis. See that? Oh, yeah, this was 0 to 1, but that's the x numbers. What are the y numbers? Okay, the y is still 0. And the y of this number, oh, how ironic. If you plug in 1 into x cubed, you still get the y is equal to 1. Okay, it's the same problem except for, this distance now. When I say f minus g, I'm going to call this my f, and it has to be solved for x. This is x equals to 1, so it's already solved for x. This function becomes my g, and g, I have to solve the function, let's see, it was y equals to x cubed, solve it for x, cube root of y equals to x. So that side that we used before will be the right function minus the left function in terms of y. So I get, well, no, solve for x. It's in terms of y. So this is 1. Come on, right. 1 minus, this function is cube root of x. That's how long each of these pieces are. Okay, volume is, the square. Will the square be a different area? well, it's going to be, yeah, the square is going to be a different area than before. Let me do it better. The square now will be 1 minus cube root of x by 1 minus cube root of x. So my area will be 1 minus cube root of x squared. So volume is from 0 to 1 of 1 minus cube root of x all squared dx. Do I want to do it by hand or with a calculator? Please do it with a calculator. I'm going to go look at the answer. I'm going to write the answer out. That way you can see if you're right. So I'm going to count to 30 in my head so you're not cheating. Okay, the one thing that I should have said, it's not dx though now. The thicknesses are dy. So let me put dy here. Not that it changes what you're going to do. The answer is, drum roll, I think it's 0.1. Double check the calculator. Okay. Semicircles, same region. Well, we go back up here. I have a picture of it over here. Here it is, same region. And let me make a copy of this piece here because, well, let me move it now. Well, oh yeah, it's moving. Let me make a copy of this so I have two of them still. Okay, move it out of the way. So semicircles. Remember, I have to make those semicircles perpendicular to the y-axis. So my circles are going this way. Circles are going this way. Semicircles. So if I zoom in on it, you're going to see that there's a semicircle coming out like this, coming out like this, coming out like this. Oh, it's a real pretty coming out like this, coming out like this. It's really pretty. We already know what this measurement is straight across. And so the area of a semicircle is 1/2 pi r squared. And my r has to be 1/2 of what that distance was. And if you recall, that distance was 1 minus cube root of x. Because this whole distance is 1 minus cube root 1 minus the cube root of x. Half of that distance is my r. So I have 1/2, I forgot my pi r squared. So set the limits are the same. Volume will be integrate 0 to 1 on the y-axis. Pi over 2 can just factor out over here. And I'm going to take the 1 minus cube root of x squared. Well, interesting. Did I already do 1 minus cube root of x squared with that other problem down here? No, it wasn't. That was the one I did wrong. This one here. Yeah, I already did 1 minus cube root of x squared. That was 0.1. And my calculator also said it was 0.1. So I'm just going to take that answer as this, take it back upstairs here, and say is dy is pi over 2 times the 0.1. I don't mind that. Now, some books won't let you use a decimal with a fraction. So if you multiply top and bottom both by a 10, that moves the decimal over 1, and that moves this decimal over 1. So you could also say it's the same thing as pi over 20. I'm just saying. My calculator gave that answer, but the teacher guide does not. Something is wrong with my pi over 2. Did I... 1/2 of... I don't know what... It's not right. I think I'm right. I don't know. I don't know how he would have gotten a pi over 8. Am I missing something? If you tell me, then I will. Semicircle. That's a semicircle. The whole circle's pi r squared. I only want. Oh, let me look at if I did my math right on that half of that side. The other problem. Oh no, I already know what it was. It was 1. Oh, maybe that's it. 1 minus the cube root. But I need half of that. Did I do that? I did. I need. Oh, I see what I did wrong. Um, I need I need half of. Let me see. It is half of the 1 minus cube root of x. Yeah, check this out. I think this might do it. Maybe. This is the r. I don't have the whole thing being squared. So there is a pi, but r squared means this has to be squared, which gives me a 1/2 times 1/2 is a 1/4. 1 minus cube root of x. There's my radius. So now when I plug that in, I'm really and I got my pi. Oh, yeah, I still need area is 1/2 of pi times this squared, 1/4, 1 minus cube root of x. And then that's going to be squared. Okay, there's my 1/8. All right, I found my mistake. That's an eighth. That's an eighth. And that would be an 80. All right, okay. I'm happy now. We got one more to go. I wasn't going to do all these. I shouldn't have done all these. Here goes. Same picture, equilateral triangles. Okay, so the triangles are perpendicular to the y-axis, so they're doing an equilateral triangle doing this. Smaller you go, equilateral. So whatever this side is, all of these sides were the same. We already know what that side is. The side was equal to 1 minus the cube root of x. Okay? And we already know the area of an equilateral triangle was 4. Was it 4 over the square root of 3 times the side squared? Double check. Yes, no? It's no. That's the wrong order. It's square root of 3 over 4, you silly goose, times the side squared. So here goes. Volume is from 0 to 1 of the square root of 3 over 4 times the 1 minus cube root of... why am I using cube root of x? It was cube root of y each time, wasn't it? Every one of these problems should have been a y. It doesn't really matter because I am doing a dy. So that should be a y, cube root of y. Oh, I'm so embarrassed. I just thought of that. Every one of these should have been a y. Let me just do them all in blue. A y. Let me do a dark blue. Cube root of y. Cube root of y. Cube root of y. Cube root of y. I'm not going to do every single one. Are you kidding? Who cares, right? I can't stop. That was doing the x's anyway. So then this one was cube root of y, cube root of y, cube root of y, cube root of y, cube root of y. Okay, I feel better now. Okay, doesn't really change anything. Matter of fact, when you use your calculator to integrate, you still use the letter x. So go figure. All right. 1 minus cube. Why did I just now think of that? I don't know why. 1 minus cube root of y dy. And that has to be, was that squared? Side squared, right? Yes. And I did that answer somewhere. I'm going to factor out the square root of 3 over 4. Integrate 0 to 1 of just the 1 minus cube root of y squared dy. Where did I do that one? That was a square. I did that one. The square. Where was the square at? Squares. Squares. Nope. That was a pretty semicircles. Yeah, that was a square going the wrong way. Here was the square going the right way. That answer was 0.1. 1 minus cube root of y was... Oh, wait. Is it square root of this one? Well, yeah. I had to square it. There's a squared, yes. So that was 0.1. So go back up. Put on up. Recycling my work. That's square root of 3 over 4 times 0.1. And multiply by 10, multiply by 10. I'm going to go with square root of 3 over 40. And that's my story, and I'm sticking to it. FYI, all the answers are correct now, once I fixed up my mistake. All right. Anybody else have any questions? Well, of course not, because you're not real. You're Memorex. These are very good practice problems, guys. Catch you later.